Okay, let's dive into this. Today, we are unpacking a truly fascinating explainer based on a 2026 paper published in the International Journal of Computer Science and Engineering Research, or IJCSER. Now, the paper we're looking at is titled Quantum Intelligence Turbulence-Aware Crowd Flow Conflict Modeling for Early Congestion Prediction, and it's by researchers Satvik Rangu, Alu Sivakumar, and Sura Manoj. I know. That title sounds incredibly dense, right? Literally a mouthful. But seriously, don't let the complex terminology intimidate you, because by the time we wrap up this explainer, you're going to see exactly how groundbreaking this research actually is, and more importantly, how it translates into keeping everyday people like you and me safe. So, I want you to imagine for a second that you're at a massive outdoor music festival. Or maybe you're exiting a stadium after a really huge championship game. There are thousands upon thousands of people moving around you. And then, suddenly, the pathways narrow down and things start to get tight, like really tight. We've all seen the devastating news stories where these overcrowded situations turn tragic, haven't we? To understand the solution to this, we first have to thoroughly understand the threat. So the central mystery we are unpacking today is simply this. Can we predict a stampede before it happens? Can a new, highly advanced, camera-based AI detective actually spot the invisible underlying signs of a crowd crush well before anyone is actually in physical danger?
Section 1. The danger of overcrowding. The core problem.
Severe crowd congestion leads to dangerous conditions like panic and stampedes. And the reality behind that statement is honestly terrifying. Because when overcrowded areas reach a critical density, human movement completely stops being a matter of individual choice. You literally can't just decide to stop walking or, turn around and go back. The crowd starts acting like a fluid under immense physical pressure. And because these conditions are so incredibly dangerous and escalate so fast, the absolute ultimate goal for anyone managing a large event isn't just reacting to a panic once it starts. No, the goal is predicting that congestion at a much, much earlier stage, well before panic ever even has a chance to set in. If we can predict it early, event organizers can redirect traffic, open up new exits, and basically keep the whole crowd safely managed.
Moving right along to Section 2, Tracking Motion and Flow, Pedestrian Dynamics.
So how exactly do we accomplish that early prediction? Well, this is where we introduce the hero of our story. It's a specialized camera-based system designed to deeply analyze pedestrian dynamics to keep their movement free-flowing. Now, what's really interesting about this slide is the crucial technical concept making this whole system work. It's called optical flow, which is the calculation of the direction and velocity of every individual motion in a video. Think about it like this. Imagine you're standing on a bridge looking down at a fast-moving river. Instead of just seeing one big, continuous body of water, what if you possess the ability to track the exact speed and the exact direction of every single microscopic drop of water simultaneously? That is essentially what this AI system does with human crowds. It watches individual movements in a live video feed, calculating exactly where and how fast every single person is moving at any given millisecond. It's wild.
Let's walk through how the researchers structured this methodology step by step. Step 1, capture the crowd video, usually using high-angle cameras. Step 2, calculate that optical flow we just talked about, dynamically tracking all those individual human drops of water. Then Step 3 is where the AI really gets smart. Cluster motion vectors. The system actively groups together people who are moving in the exact same direction at the exact same speed. By clustering these vectors, the AI kind of strips away all the random visual noise and discovers the massive key flow patterns of the whole crowd. And finally, Step 4, identify conflict zones. Let's see how this all builds into identifying those specific areas of danger.
Which brings us to Section 3, Identifying Zones of Conflict, where flows clash.
Okay, so now we are narrowing our focus from the broad, overall crowd down to the exact geographical points where the smooth, free-flowing movement of pedestrians is dangerously interrupted. Take a look at this comparison here. Free-flowing crowds versus clashing counterflows. When people are all walking in the same general direction, say everyone is heading straight toward the main exit, the optical flow is super smooth and orderly. But what happens when two distinct, heavy groups of people walk directly toward each other? Well, the researchers call these counterflows. When these opposing counterflows come together and clash, the camera-based system instantly flags these intersections as conflict zones. And importantly, it doesn't just flag them once and forget about them, right? It actively monitors the dynamics of these zones over the passage of time to continuously assess the building risks of congestion.
And that continuous monitoring leads us to a major conceptual breakthrough in the paper, the Turbulence Index, a metric to quantify motion field instability. And this brilliantly illustrates the absolute core innovation of the study. The researchers literally took a concept straight out of fluid dynamics, turbulence. You know, exactly like what you experience on a really bumpy airplane ride when invisible air currents clash, and they mapped it directly onto human pedestrian dynamics. This index is the secret sauce of the system. It puts a hard, objective, quantifiable number on just how unstable, chaotic, and dangerous a crowd's movement is becoming right inside those specific conflict zones.
Section 4. Predicting the breaking point. Predicting congestion.
So we have our conflict zones identified, and we have our turbulence index calculated. But how do the researchers actually utilize this rich data to look into the future and predict a stampede? Well, to prove their concept, they feed all these extracted features into 3 distinct prediction models. First, they use a simple linear model, mostly just to establish a baseline. Second, they use a Kalman filter. Now, this is a highly effective mathematical algorithm actually used a lot in aerospace and navigation to estimate unknown variables over time. And third, they utilize an LSTM neural network, which stands for long short-term memory. This is a highly advanced artificial intelligence model, perfectly suited for recognizing incredibly complex patterns in time series data. By processing all those motion instability features through these 3 models, the system can approximate the exact amount of time before severe congestion hits, entirely before it ever takes place.
Finally, Section 5. Proven Early Congestion Prediction. Real-world results. So, the big question, did it actually work? Let's move to the real climax of our explainer here. The results from their experiments using actual, real crowd footage were absolutely definitive. As the researchers state themselves, incorporation of awareness of turbulence can provide reliable early congestion indicator, and this method is more effective than purely basic methods. So, the crucial point is this. By programming an AI to specifically look for turbulence in human movement, rather than just, lazily counting the total number of heads standing in a room, this advanced, turbulence-aware modeling successfully and reliably outperforms older, basic methods. It genuinely acts as an early warning system, predicting danger long before the human eye could ever spot it.
Which leaves us with a final real-world thought to chew on. How might turbulence-aware AI change the way you feel at your next major concert or sporting event? Just knowing that invisible camera-based AI detectives could be constantly analyzing the optical flow of the crowd, actively searching for the very first signs of human turbulence to predict and prevent stampedes before a single person ever feels squeezed, it is an absolutely fascinating application of intelligence and crowd modeling that could literally save thousands of lives. Thank you so much for joining me to explore this incredible research. Take these insights with you and stay safely curious.